All right, students. So this question is again from mechanics. Very good question. Let's read the question first. Please don't forget to subscribe to this channel. You will see some excellent quality content with detailed physics explanation, which no other channel provides. Thank you. All right. So a block of mass 2 kg is having a velocity of 4 root 5. So that's your block, and the velocity is given. It is acted upon by an external force of 3x square minus 12x. You have to find the velocity of this block when its position is 2 meters. So let's assume it starts from x is equal to 0. It reaches some position which is 2 meters. Okay. So this is your 2 meter under the influence of this external force. Okay. Now let's talk about the nature of the question. See, if there is an external force, there is going to be an acceleration, right? So the Newton's laws hold good. Okay, but the only difference, the keyword that you should enter your mind, see, most of the question it is given that force is equal to 10 Newton, 15 Newton, so on and so forth. The number is given. In this question, you're given force is equal to 3x square minus 12x. This type of number is not given to you. Therefore, what you're talking about, the big word that should enter your mind is that we are dealing with a variable force, a force which varies with distance or position of the body. X represents position. So, as the position of the body changes, the quantity of force you apply is going to change. If you put x is equal to 1, the force is different. If you put x is equal to 2, the force is different, right? So, force is variable, and when you get variable force question, right, what is that technique? You one technique obviously is you have been doing is apply uh, Newton's law, F is equal to ma, and what you've been doing is using this v square minus u square is equal to 2as. But remember, here the acceleration is not uniform. It's not a uniform acceleration because the force is variable. Therefore, acceleration is non-uniform, right? This equation, v square minus u square is equal to 2s, can only be applied if you have uniform acceleration. So we cannot use this, right? So this technique is gone to find out the velocity at some time t when the distance covered or the displacement is s. You cannot use this. It's a variable force. I will reduce the size of the question now. I hope you have read it by now, and let's solve it together. Okay. So I know it's a non-uniform acceleration, and therefore the strategy to solve such a question is to use calculus. Non-uniform acceleration. So first thing, look at the question, establish uniform acceleration, non-uniform acceleration. Uniform acceleration comes from a fixed force. Non-uniform acceleration comes from a non-uniform force. What's a non-uniform force? Which does not vary with time or position. It remains constant. Okay. So this is not the case here. We have a non-uniform force. I'm just repeating myself so that it enters your mind that while solving the questions, you're careful not to get carried away straight away by v square minus u square to find the final velocity. You're supposed to find velocity here also at this position. Don't use that. Let's see the trick of calculus. Now we know what is f is equal to this. Therefore, if you want to find out the equation of its velocity in terms of this, so can I write this as m dv by dt is equal to 3x square minus 12x, right? But this is still v, we still need x, right? So what you can do, you can write this as m, okay, d square x by dt square is equal to 3x square minus 12x, right? So you have some equation being created, which is more like a differential equation in x. We know the value of m, we can always put it here. So now you know what is the acceleration equal to, right? So acceleration is m into dv by dt. And then dv by dt has been written in a certain manner. But tell me, if I bring this below and I take dt on the other side, this will become slightly difficult and complicated to solve. So, but technically this is a correct equation. But does it help me in actually solving the problem is the question. Okay. So let's do one thing. Let's rewrite this and say this is 2 dv by dt is equal to 3x square minus 12x. Okay. Now, still the same, right? Now, what I'm trying to do is make your life simple. Calculus knowledge is required. What I do is I multiply this and divide this by dx. Okay, and this also becomes, so dv by dx and d multiply by dx by dt is equal to 3x square minus 12x. See, what I've done is I've introduced extra dx because this was not making sense to me. I actually would need to know a lot of differential equation to be solved this, which I know if you go to my playlist, but it's not required. Let's use this trick of multiply and divide by dx. What does it help you with? It tells you that 2 dv by dx multiplied by velocity is equal to 3x square minus 12x, right? And if I take the dx on the other side, so 2 is your mass, okay? So 2 dv multiplied by v is equal to 3x square minus 12x into dx. Now, this is something which is reasonable, right? We know it's a y d y and another side is x. So two variables, very simple to integrate. Let's integrate now. So I will integrate, I will get a v square by 2 multiply by 2 is equal to 3x cubed by 3 minus 12x squared by 2 plus a constant, right? So we started with non-uniform acceleration, and now this has become more of mathematical trick now. Okay. Now we know how to calculate C. We should see, are there conditions available in the equation which can help us get the value of C. So if I notice at x is equal to 0, when the motion started, the velocity is 4 root 5. Okay. So v square, which is the initial velocity, actually divided by 2. So I will just put the value here, in fact. So let me just put the value here. So this is my value, right? My value is 4 root 5 square. This 2 goes away. And the position to start with is 0, if you read the question, okay? Because you want to find out when the position is 2, what happens. This is some general expression, for the force. And you want to find out the velocity. So 3, 0, 0, and C, right? So what's your C equal to? You get 16 into 5, C is equal to 80. And what's your equation now? So you have found the value of constant. So velocity square is equal to 3. Okay, so this also cancels, right? 3 and 3, this becomes 6. So is equal to, let me just rub this off. So this will become x cube minus 6x squared plus 80, right? So this is the relationship between the velocity and position. That is what we wanted, because we want to find out what is the velocity when the position is 2 meters. So let's say velocity is equal to 2 cube minus 6 into 2. I'm putting x is equal to 2, where I need to find the velocity. 2 square plus 80. So V square is equal to 88 minus 24, and V square is equal to, this will become 64, and V will come out to be under root of 64 is equal to 8 meter per second. Let's say if we have a choice of 8 meter per second. Okay, let me just enlarge the question. See the choice number first. It talks about 8. So our correct answer is 8. I have a huge motion in the straight line playlist also, where numerous tricks pertaining to calculus based questions have also been given. Use that playlist to understand how to solve when the acceleration is non-uniform, because you're dealing with non-uniform acceleration. You cannot use this equation. You have to use the trick of calculus, which you just saw. It is one of the tricks. There are many other tricks you will see in the playlist. I think there are more than 200 problems which I've solved. So don't forget to watch that. So I will just revise what we studied. We studied non-uniform force or a variable force. Acceleration is not constant. It depends on, in this case, position. Sometimes it can depend on the time. The way to approach these questions is to use calculus. And within calculus, there are certain tricks which showed you one of them, to simplify the differential equation you create. If you just do it like this, you still have a time, position, and becomes a bit complicated. So the simplified manner was this. Okay. So these are the fundamental steps you have to take. And of course, you were able to find the initial conditions, use the initial condition to find the value of C. So during the motion, you know what happened. Use that also to get the value of C. That is called as some initial condition. Or maybe they give you some condition or a situation in the question saying that at x is equal to 1, the velocity is this. Even that can be used to calculate C, right? So I hope you like the description of it. It is just not a solution, but an attempt to make you understand and help you retain the concept. Thank you very much for your time, and look forward to see you soon.